Example 7.7. I will read the question here. That is, the angular speed of a motor is increased from 1200 rpm to 3120 rpm in 16 seconds. What is the angular acceleration, assuming that acceleration to be uniform? Second, how many revolutions does the engine make during this time? This time is 16 seconds. Okay. The angular speed of a motor wheel is given by initial angular velocity, that is 1200 rpm, and final angular velocity is 3120 rpm. Okay. So then we have to find out the uh, angular acceleration. Okay. So first write down the given data. So initial angular vela sorry initial angular velocity, initial angular velocity or speed, that is omega naught is equal to 1200 rpm. Okay. So then final angular velocity omega is given, that is 3120 rpm. Okay. But we should convert this rpm into radians per second. rpm means revolutions per minute. So while discussing the angular displacement, we are discussing about this rpm. Okay. 1 rpm means one revolution per minute. Per minute means that is by minute. Okay, that is equal to how much? In one revolution it is completed 2 pi radians. Minute means 60 seconds. Okay, so now we can convert this one revolution into radians, means that is we have to multiply this 2 pi by 60 seconds. Okay, here 1200 rpm is there. So 1 rpm is equal to 2 pi by 60 seconds. So then this initial angular uh, velocity or speed is becomes now, that is 1200 rpm. 1 rpm is equal to, the revolutions per minute is equal to 2 pi by 60 radians per second. This is radians per second. Okay. Uh, sorry, it is not visible here, so I will write it bottom side. Okay. So 1 rpm, 1 rpm is equal to 2 pi radians by 60 seconds. 2 pi radians per 60 seconds. Okay. rpm, revolutions per minute. Okay, revolutions per minute means per one revolution by minute, one revolution in minute, that is equal to rpm. So in one revolution it is completed 2 pi radians. In one revolution means it is completed one cycle. So it is makes an angle, that is 2 pi radians, and it is taking per minute. So that's why it is 1 minute is equal to 60 seconds. So 1 rpm is nothing but it is 2 pi by 60 radians per second. Okay. So means now this rpm we have to convert into radians per second. So if you want to convert that, so 1 rpm is equal to how much? 2 pi by 60 radians. We have to multiply by the 2 pi by 60 radians per second. So here this is equal to 2 pi by 60 radians per second. It is equal to 1 rpm. So then write down here, this is 0, 0 will cancel. 6 1s are 6 2s are. So here another 0 is there, that is 20, that is equal to omega naught is equal to 2 pi into 20, that is 40 pi radians per second. Like that, final angular speed, that is omega is equal to, that is 3120 revolution, that is rpm. So it is equal to 3120 into 1 rpm is equal to 2 pi by 60 radians per second. So it is equal to 3120 into, that is, sorry, okay, so here cuttings 0 0 is cancelled, and 6 1 ja, 6 5 ja, and 6 2 ja. Okay, then this is 52 into 2, that is 104 pi radians per second. Okay, now we got the final angular velocity and initial angular velocity. Then find out the alpha. What is the alpha? Alpha is equal to omega minus omega naught by t, and that is equal to omega is 104 pi minus omega naught is 40 pi by time is 60 seconds. Okay, remember that this is what how much taking the time from initial angular velocity to final angular velocity, that is 16, that time is 16 seconds. Okay, so it is equal to 104 minus 40, so that is equal to 64 pi by 16, 16 ones are 16 4s are. Okay, so that is equal to, it is equal to 4 pi radians per second square. It is because of alpha. Okay, this is the alpha. Then second question is, the second question is the angular displacement in time t is given by. Okay, so actually they want to how many revolutions does the engine make during this time, means while changing from 1200 rpm to 3120 rpm, it is completed some revolutions. Okay, in that interval of time, the time is given by here, time is equal to 60 seconds. In this 16 seconds, how many revolutions that is completed? Okay, that is they want to hear. Okay, so we know that angular displacement. What is the angular displacement? So for suppose there is one particle, if it is completed one cycle. Okay, so if a particle is completed one cycle, then it is making 2 pi radians. Okay, 2 pi revolutions in one cycle. For that it is taking the time something. Okay, that is distance, angular distance by time. Angular distance is 2 pi per one revolution. Okay, if it is completed two revolutions, that is 2 pi into 2 by whatever the time is taken t. Okay, then like that uh, three in for suppose it is completed n cycles, that is equal to 2 pi by t into n revolutions for n revolution. Okay, then we know that is theta is equal to, this is angular displacement, total theta is equal to, that is equal to 2 pi n by t. Okay, this is what our sorry number of revolutions. Okay, so this is 2 pi into n. Okay, 2 pi is uh, the angular displacement in one revolution. 2 pi n means angular displacement in n uh, number of revolutions. Okay, in one revolution it is completed one cycle, that makes 2 pi radians. If n number of revolutions completed, 2 pi into n, that is equal to angular displacement. If this angular displacement, we can divide both sides by 2 pi, and it is how much? 2 pi. Then 2 pi, this 2 pi cancel, and this is equal to how much? N, that is equal to theta by 2 pi. Okay, so then so now we have to find out that this theta angular displacement, and it is divided by the 2 pi. Then we got the n number of revolutions. I think it is understand. Okay, so according to the angular displacement, so in one revolution the angular displacement is 2 pi. Okay, so in one revolutions angular displacement theta is equal to 2 pi. Okay, so in n, if it is completed n number of revolutions, then angular displacement is equal to 2 pi n. Then uh, both sides we are dividing by 2 pi, that is 2 pi, and it is equal to 2 pi n by 2 pi. Okay, 1 2 pi 1 2 pi cancel, then n is equal to, so it is n, and this is equal to theta by 2 pi. Okay, so this n is the number of revolutions. Now we want to number of revolutions. For that we have to find out the angular displacement theta, and it can be divided by 2 pi. Then we got the number of revolutions. So for that angular displacement, we have a equation, that is theta is equal to angular displacement. Angular displacement theta is equal to omega naught plus omega naught t plus half into alpha t square. This is our formula. Second kinematical equation in rotational motion. So it is equal to omega naught. Omega naught is equal to 40 pi into time is 16 seconds plus half into alpha. Alpha is equal to 4 pi. It is equal to 4 pi into t square. T square is 16 square. Then it is equal to, this is 2 1s are 2 2s are. Okay, so here 16 4s are 640. Okay, 16 4s are 64, and we have a 0, that is 640 pi plus this is 2 pi. Okay, 16 16s are 256, and into 2, that is equal to 512. So this is 512 pi. Okay, so it is equal to 600 plus 500, that is 1100. 1140 plus 12, that is 52 pi. This is our angular displacement. Now this angular displacement theta, that is divided by 2 pi. Then we got the number of revolutions, that is theta by 2 pi, and that is equal to, theta is equal to 1152 pi by 2 pi. So 1 pi cancel, and it is equal to 2 1s are 2 5s are, and here this is 2 7s are, and it is 2, that is equal to 572 revolutions. Okay, so this is our n. So in 16 seconds it is completed 572 revolutions.